So here we've got two contracts to consider, and note the starting salary in January is 3,000 on contract A and 1,000 on contract B, but then they increase each month, I'm going to assume, yeah. So in February it's going to be 3,000 plus 500, in March another 500, and so the contract for 1 year. And over here, 1,000 in January, then increase by 25%, so that cool tip about multiplying by 1.25 to find 125%, that's key. So we're going to answer this in maybe three different ways. The first way is going to be purely an applications method, and we're going to use a spreadsheet method. So if we go to our spreadsheet here, I've already put N here, I'll put contract A here and contract B here. So N, if we scroll all the way back to the top, N is going to be the number of months, and we're going to assign 1 to January. So when we're communicating this down on paper, we will say let N be the number of months where January equals 1, and then we're just going to go all the way up to 12. Now we can type in 1 to 12, or we can just use this column like a conventional spreadsheet. We can put a formula equals the cell above, and you can just type in A1 like this, and then plus 1. We press enter. Now there's two ways of filling this down. There's a shortcut way and there's a long menu way. We'll do both ways. So if we go to menu, there's data, and then there's fill, and then it doesn't look like anything's happening, but if you press the down arrow, it opens up these nice little dashed lines, and once you've got as far down as you want to fill, press enter and it's there. Okay. Now if I just go and delete that again and then show you the alternate way, you're still going to put in equals the cell above, A1 plus 1, and press enter, and then you can press Control Center and the hand, oh my bad, let me press escape, I've got to be on the cell I want to copy down, Control Center, and the hand kind of grabs this number 2, and again if you press the down arrow, you are basically copying down not the number 2 but the formula, and the formula says add 1 to the cell above, and there you go. Now we're just going to do a similar thing now for contract A. Now if you remember contract A in January, let's just cross check, it was 3,000, so there you go, type in 3,000, and then obviously in here equals the cell above, so this is now B1, and we go plus 500, and we're just going to fill that down, so I'm going to go Control Center and then arrows down. I'm going to go to the final column, contract B, let's just check again, 1,000 and then increasing by 25%, so 1,000 and then equals the cell above. Now we're increasing by 25%, so we are going to times by 1.25, so times by 1.25, and again click, I'll go the other way, menu, data, fill, and then the arrows down, and that's it. But now we've got to be careful, because what we have here for each of these are actually the physical amount paid each month. So you can clearly see that every single month A is paid more, paying more money than B. It's only when we get to the 11th month, November, that contract B starts to pay more in that month, and more definitely in the final month of December. But overall, contract A each month is more. So I'm pretty sure that the sum of all 12 months for contract A will be more than B. So what we want to do obviously is find the sum of all these 12 months. Okay. But equally, it'd be nice to have a cumulative sum, just to see after 5 months which contract pays more, after 7 months in total which contracts paid more. And we've got that actually with the built-in function. So if I go up to here and just go to equals, and then we can go to menu, and we can go to data, and we can go to list operations. Now in list operations you've got this cumulative sum list. So I could use spreadsheet formulas and try to add together certain cells, but this cumulative sum list is quite powerful. So if I click cumulative sum list, and we're just going to say A. So when we type in A, notice it grabs A, the variable, and it's bold in here now. So I press enter, But we'll always ask you this, is it a column reference? Well, column A is this first one. These are the number of years. This is definitely a variable reference, okay? And look at that, it's actually got the summation of all the months. So for instance, this here, 52,500, is the sum of the first 10 months salary from contract A. Now we'll just go across here. Let's put this now, again, we're going to go all the way to the top, equals here. Actually, let's see if I need to put equals in here because in this row, these are automatically formulas. So let's just click menu. Let's go to data. Let's go to list operations because we're operating on a list of numbers, cumulative sum list. And this is B, enter. And again, it's a variable reference, okay. Syntax error during insertion. Okay. So it looks like we do have to type in the equals. At the start, it didn't automatically appear. That's my bad. And it is a variable reference. Beautiful. So let's just summarize. If I grab some of these column widths, make them a little bit smaller, we should get everything on one screen. As we scroll back now, make the ends a bit smaller. There we go. So over here now, you can see that after 5 months, 20,000 is the total salary for 5 months worth of work for contract A, and it's only 8,200 for contract B. And if we go all the way to the end, you can see that 69,000 is the sum for the 12 months for contract A, and 54,000 for contract B. Now clearly, contract A is better, but if the contract continued for another 12 months, then pretty much contract B, you can see, is going to increase in value exponentially, because it's increasing by 25%, but contract A is only increasing linearly, because it's increasing by 500 each month. So that's quite powerful. But there are other ways we can do this, and the other ways involve a variety of things. So what I'm going to do is I'm just going to go doc, insert a new problem, and then I'm going to have another list in spreadsheets. Now, by doing that, it means if I type in n again here, then it won't default to the previous sets of n's which were attached to the problem set 1 point. So here we're on 2 point. So let's just go back again. So contract A, contract B. Now, there are slightly different ways of doing this, and the other ways rely on you understanding that actually there's a sequence to be had here. So if I go back to 1.2, these numbers here, the actual amounts per month, actually follow an arithmetic sequence, and there's a formula for the nth term of an arithmetic sequence. And it's listed in the formula book, but it doesn't take a lot of working out. That the first term is 3,000, okay? And so if I just go to my new problem page, if I go doc, insert a new calculator page, then you think about it, it's 3,000 plus n minus 1 times 500, which kind of makes sense, right? It says it's an empty set because there's nothing in place for n. But this makes sense that this is the nth term formula for contract A. And the contract B is 1,000, and this will be times 1.25 to the exponent of n minus 1. And that makes sense, right? Because you can try it out. If you substitute n equals 1 in here, you'll get 1,000. n equals 2, you'll get 1,000 times 1.25. So this next method relies on you being able to establish the nth term formula. And now we're going to combine this with the magic sigma button. So next to the number 9, you've got a menu button. You can open up the sigma notation. Now sigma means add up, basically. So we add up a list of values. So here we're going to put n equals 1 up to 12, and we are going to just copy. Again, you can type this in because I'm using my laptop. It's easy to copy and paste in. And this will say substitute 1 in place of the n, then substitute 2 in place of the n, and keep going with all the integers from 1 to 12 and add them up, and that will give you 69,000. So let's go cross compare that again with this column here. The cumulative sum for contract A was 69,000. So let's go back up to here, and then we can go up, up, press enter, we copy it down, but then we obviously want to change the formula here. This is 1,000, and this is times by 1.25 to the exponent of n minus 1, and that should give us the 54,000 plus plus. If you go back to the spreadsheet here, 54,207. So pretty impressive that the sigma notation gets us there straight away. So the comparison clearly is that with the spreadsheet, you didn't need to have any real understanding about the nth term and about an nth term for an arithmetic sequence and the nth term for a geometric sequence. You could just rely on your spreadsheet skills to get there. The power, of course, of this method is you have to know a little bit about nth term formula, and then you can use the sigma notation to get there. The next method, we'll go back to a spreadsheet here. I suppose it's a little bit of both of them, and just introducing a new special feature. So in here, I'm going to put equals, and I'm going to put menu, data, and is this generate sequence I want, but it's not available by the looks of it here. So if I just press escape, and let's just delete this. If I delete the column header, and let's try this again. Let's try it in here, menu, data, generate sequence. Okay, so it looks like I can't have a column header, a variable. So the formula for u of n, well, I'm actually going to call it n here, and I'm going to go from 1 to 12, and can you see what's happened there? It's just generated a nice sequence here from 1 up to 12, which is useful. And I think you can have a column header actually. Let me put A here for contract A, and I think I just, instead of putting equals in here, I think I just put menu here. So let's go menu, data, and generate sequence again. And now here, I suppose I do need the formula for arithmetic sequence. So this is 3000 plus n minus 1 times by d, 500. And I want the first 12 terms. Okay, and there I've got it. So this is, I suppose, a slightly different way of generating all of those terms. If we compare those to this here, you can see we've got the same terms being generated. So it's just an automatic sequence generator, which is quite useful, eh? So I'll go in here, let's call this B, and let's just generate all the terms in contract B, all the monthly payments. Again, let's go for menu, data, generate sequence, and the formula here is 1000 times by 1.25 to the exponent n minus 1. Let me put that in brackets, the exponent of n minus 1, just so it's not being too confused. Actually here, let's go up to 24. Let's see if we can carry it on to 24 years. And let's do the same here. We can carry it on from 1 up to 24 years. Brilliant. And now let's just go in here, let's do the sum of the sequences again. And let's see where the crossover point is. You know, when will contract B, the sum of money earned in contract B, overtake the sum of money earned in contract A? So again, here we're going to do equals, go to menu, data, and now we've got list operations and we've got cumulative sum list. And this is the cumulative sum of contract A, and it is a variable reference. There we go. And let's go to contract B, equals menu, data, list operations, cumulative sum, and this is B, enter, it's a variable, okay. And now we're just going to compare side by side, right? And we get down to, so there it is, after 15 months, it looks like. 15 months, contract B, the total sum earned is 109,000 plus plus, and 97,500. And after 14 months, contract A is still a little bit more than contract B. So that's the power of using spreadsheets, that you can have a nice comparison. Maybe I didn't need this column here, the 1, 2, 3, because look, it just matched the row number anyway. But there you go. There is a final way, of course, and the final method relies on you having another bit of knowledge from the formula book, because the nth term of an arithmetic is given here, and of course there's a formula for the sum of n terms, and there's a formula for the sum of n terms of a geometric. So actually, if we go back to here, we could actually just work out the sum of these terms. I kind of liked using the sigma notation because it did it really quickly, but the sum of an arithmetic we can also get by doing n over 2, which is 12 divided by 2, and then that would be times by, open bracket, 2 times by u1 plus n minus 1 times by d. Okay, so that's the summation formula which is given in the formula book, which is up on the screen there. And then we do the same thing for the sum of the geometric. We'll need a fraction button in here. So this is, again, this is u of 1, which is 1000. And this is times by, in brackets, r, 1.25 to the exponent of n. And that will be minus 1. And in the denominator, r minus 1. And again, you can see we've got the same end result. So look, a real variety of ways of handling this question. And the question was, which contract should this person choose? So the original question is obviously a contract for 1 year, but we extended it to beyond 1 year because it was interesting. We can define some variables, n, s of n, or a, s of a, how we want to do it. The first technique was just by just pure spreadsheet alone. We didn't need any knowledge on formulas really, just add something to the cell above and, you know, multiply the cell above, and then we had some summation formulas. We then had a nice way of working with the sequence generator, and we had a nice way of working two ways with the kind of pure analysis part of it. We needed the nth term formula, and we used a sigma notation on the calculator, which adds up lots of terms. And the final thing was we used the formula book and the summation formula given in the formula book.